So our final topic in this chapter is talking about inequalities in two triangles. So here you're going to have two triangles either connected to each other, sharing a line, or two triangles that are separate but related in some way. Now we have two theorems to discuss. They're both kind of long, so if you need to pause, write the whole thing down, and then listen to my explanation, I will give you some time to first pause. So first one is the hinge theorem. So in the hinge theorem, it's saying if two sides of a triangle are congruent to two sides of another triangle, and the include angle of the first is larger than the include angle of the second, and that third remaining side of the first triangle is longer than the third side of the second triangle. So what you're essentially having is almost like a side angle side case from our congruent triangles. Let's say we have these two triangles right here. Let's say these two sides are both equal. So they have two sides congruent. And let's say this is 40 degrees and this is 30 degrees. What this is saying is that this angle right here, because it's bigger than this angle, this side AC has to be bigger than this side DF. So what you're going to do is you're going to set up an inequality situation to solve for the range of possibilities for this third side. So for example, if this was x and this is 12, we would know that x would have to be greater than 12. Now obviously this is a little more complex problem than we have to actually go through about solving the inequality, but that's okay. If it was the other way around, let's say this unknown was x, and then this one was 12, we would actually have to set up two inequalities, because it's true that x has to be less than 12. This has to be the smaller side, but also x can't be a negative number because the side can't be negative. In fact, x can't be 0 either. So x would also have to be greater than 0. So the true inequality for this situation would be x has to be between 0 and 12. And that's what we're going to be using the hinge theorem for, to set up relationships between those two third sides to figure out, pretty much set it up so that the one side is greater than the other one, and then make sure the other side is bigger than 0. So those are your two inequalities to set up. Now the converse is dealing with angles, so we'll talk about that once you write it down. Well, the converse is saying that pretty much a similar concept. We still need to have two congruent sides in both these triangles for this whole setup to work. Now, in addition to those two sides, we're given information about the third side for each triangle. If the third side of one triangle is greater than the third side of the other triangle, then the include angle, the side angle, would have to be bigger for the longer side than it is for the shorter side. So we'd have something like this. 20, and then like 16. Let's say we have angle A and angle B, and let's say angle A was x and angle B was 40. So what this would tell us then is this angle x has to be bigger than 40. So we set up that inequality. But also don't forget, angles have to have an upper limit in triangles. An individual angle cannot be equal to 180. So it also has to be less than 180. So this would be the true inequality for that angle. It has to be between 40 and 180. And if it was the other way around, so we would say the one inequality in terms of these two, it either has to be less than 180, or if the angle is smaller, then it also has to be greater than 0, because it has to be actually a positive value. So you have to take a look at which one is the logical sense. Okay, so let's take a look. I've got 4 problems for us to look at, one for each situation. So we have these two triangles that share this side. These two sides are equal, and again, this is a reflexive side. So I do have two sides congruent. Now, for these two angles, the bigger side is the 12, therefore the bigger angle is 39. So I would have to say 5x plus 3 is less than 39 degrees. I now need to solve this inequality. So I subtract 3 from both sides. 5x is less than 36. Divide by 5. We'll find x to be less than 7.2. So x has to be less than 7.2, but we're going to eventually reach a situation where it's going to be too big. Too small, if it keeps on going like that. So what I need to do is, I need to then also set up where, well, 5x plus 3 has to be greater than 0. So I need to subtract 3 from both sides and solve this one. So 5x is greater than negative 3. I'm going to divide both sides by 5. X has to be greater than negative 0.6. So the range of values for x to make the situation true, it has to be bigger than negative 0.6, but still less than 7.2. That's what we need to set up for this particular case. And again, we're getting these values simply because we have 39 has to be the bigger of the two sides because it's opposite the 12, whereas 5x plus 3 is opposite the 10. That's how we know 5x plus 3 is less than 39. That's how we got the x less than 7.2. And then the other piece, 5x plus 3 has to be bigger than 0. I can't get too small. It has to. There's a lower limit to it. So that's why we have this overall compound inequality solution. Now for this one, we're given two side values. Again, we have two sides congruent in each, plus our reflexive side. 50 degrees is the bigger of the two angles, and it's opposite 9x minus 2. So 9x minus 2 has to be greater than the other side, 6x plus 9. So to solve for x, we need to move things around. So I'll subtract 6x from both sides. 3x minus 2 is greater than 9. We add 2 to both sides. 3x is greater than 11. We divide by 3. X is greater than 3.6 repeating. So we have that situation. Now there is never an upper limit to the side length value because side lengths can be however big I want them to be. There is a lower limit though. So the side has to be bigger than 0 as well. Now I'm not worried about 9x minus 2 because which of the two is the smaller sides? 6x plus 9. That's the side I'm worried about. So I need to, in addition to this inequality, I need to say 6x plus 9 has to be greater than 0. So we subtract 9 from both sides. 6x is greater than negative 9. We divide by 6. X is greater than negative 1.5. So there's my inequality. This x value right here, the piece of the side, has to be greater than negative 1.5, but still less than 3.6 repeating. And again, all comes down to setting up the correct inequalities. 9x minus 2 has to be bigger because it's opposite a bigger angle. So that's how we got the 3.6 repeating. But also 6x plus 9 must be bigger than 0 because the side length cannot be negative and it cannot be 0 either. Okay. Pause for a second. Sorry, my notes, I realized I used the wrong value here. So we have our two triangles again. We have two sides in each triangle. Our angles are the ones of the unknown. So this side is 24, this side is 16. So this 7x minus 4 has to be the bigger of the two angles. So I'm going to say 7x minus 4 is greater than 80. So to solve, we have to add 4 to both sides. 7x is greater than 84. Divide both sides by 7. X has to be greater than 12. In order for this triangle situation to be true, x has to be bigger than 12. Because this has to be bigger than 80, because the 24 is bigger than 16. So x can get pretty big, but again, there is an upper limit to the angle values inside a triangle. This value right here, if we're looking at the upper limit, has to be less than 180. Because if I get this to equal 180, I no longer have a triangle, so it has to be less than it. So 7x, when we add 4 to both sides, has to be less than 184. And I divide both sides by 7. Look at x has to be less than 26.286. So there's my lower limit. X has to be bigger than 12, but it has to be less than 26.286. So my inequality is 12 less than x, less than 26.286. But again, we knew to set up this first inequality because 7x minus 4 must be bigger than 80. Because the side opposite this angle is 24, opposite this one is 16, this is the bigger side, therefore this is the bigger angle. We know to set up the other inequality, because if this is going to be bigger than 80, it eventually will have to reach 180, and that's too big then. That's why it has to be less than 180. Alright, last one dealing with sides. So we have these two sides right here with these two angles. Obviously not drawn to scale. This angle is 65 degrees, this angle is 70 degrees. Since this angle is bigger, 24 is bigger than 6x minus 10. So I need to solve this inequality. 6x minus 10 has to be less than 24. So I add 10 to both sides. 6x is less than 34. I divide by 6. X is going to be less than 5.6 repeating. Now, since we're dealing with sides, there is a lower limit to this side value. 6x minus 10 must be greater than 0. So we have to add 10 to both sides. 6x is greater than 10. Divide by 6. X is greater than 1.6 repeating. So our x values will fall between 1.6 repeating and 5.6 repeating. So that's how you do these problems. You need to set up two inequalities for angles always. Your first one dealing with how is the angle related to the other angle, whether it's greater than the other angle or is it less than the other angle. And the second inequality is based off that original statement. If this angle is less than the other one, it must also still be greater than 0. If it's greater than the other angle, it must be less than 180. So it all depends on which one the second situation has to be. As for sides, you set up your first inequality based on whatever it is. And if the side in question is the variable, and it's less than the other side, you need to then set up is greater than 0. So we can actually solve for what the lower limit actually has to be. If we go back to this example, let's say, for example, if this was my x I wanted to solve for, and then this side right here was just, let's just say it was 14. This is the bigger side. There's no upper limit to a side value. So once you solve the first inequality, you're done. But, as we had in this situation, the smaller side did have a variable, therefore it needs a lower limit. So take that into account. Okay, so that's it for this chapter involving angles inside a triangle. So next time we're going to talk about quadrilaterals in chapter 6. So I'll see you next time.